So God bless everyone. My name is Macabawe. For this video, I'm gonna report my assigned topic entitled Cell Growth and Development and Cell Mortality, Cell Lineage Immortality. So the objectives, so at the end of the lesson, the student should know the cell division, the 3 stages of cell cycle, the difference between 4 pieces of mitosis, the differences between normal and cancer cells. So cell growth, division, and reproduction. So why do cells divide? To reproduce, to grow bigger, to repair injuries. So that's why ang cell is needed siya mag-divide to reproduce, to grow bigger, and to repair injuries. So surface area to volume. If a cell gets to be too large, it would be too hard for the cell to get enough oxygen and other nutrients in and waste product out. So, if ang cell gani is kanang too large na siya, it means ang cell is kanang maglisod na siya kuha og enough oxygen or other nutrients na kailangan or needed sa cell. So, the volume of a cell increases faster than the surface area of the cell. When this increase happen, the cell faces some problems. So, if ang cell is mag-increase na gani na siya, is mag-lead na siya kanang something problem sa imuhang cell. So that's why na ang cell is needed siya to divide. So cell lifespan. The average lifespan of a cell depend on the type of cell it is. There are approximately 10 trillion cells and 200 different types of cells in an average human body. Every minute, an average of 300 million of the body cells die. In the vast majority of cases, these cells are quickly replaced by new cells through a process of cell division. So, diba we are composed of trillions of cells. So, every minute, ang average sa body cells die is 300 million. So, katong mga cell na nag-stop nag-function i-replace to by a new cell. So katong mga cell nag-replace is ginatawag to na process as cell division. Ginatawag to na process as a cell division. So cell divide at different rates. The rate of cell division varies with the need for the type of cell. So, cell type and approximately lifespan. So, ang skin cell, iyang approximate lifespan is 2 weeks. And then, ang red blood cell, approximate lifespan 4 months. So, ang 4 months is red blood cell. Ang liver cell is 300 to 500 days. Ang intestine internal lining is 4 to 5 days. And then, an intestine muscle and other tissues is 16 years. So, take note na ang intestine internal lining, 4 to 5 days, while ang intestine muscle and other tissues, 16 years. So, kana ang approximate lifespan sa mga cell type na akong gipang-ingon, which are skin cell, red blood cell, liver cell, intestine internal lining, and intestine muscle and other tissues. So cell division is needed to grow. Most organisms grow by producing more cells. So, ang cell division is needed po siya to repair wounds and damaged cells. And then, to develop and change. So, pareha sa akong giingon na ang cell division is needed jud siya ma-divide. It's because to grow, to repair, and to develop and change. So, cell division. The formation of new cells is essential for an organism to grow, develop, and repair damaged cells and create new organism. So, for able to grow, develop, and repair damaged cells and create new organism or new cells, old cells must die. So, the process by one cells divide into 2 cells is ginatawag to siya na cell division. So, 2 types of cell division. Na 2 types ang cell division. Number 1, mitosis. Number 2 is meiosis. So, ang mitosis, cell division is body cells. Sa body cells ang mitosis. While ang meiosis, cell division in 6 cells. So, after dividing sa after dividing sa new cells is mag-rest na sila for a while, and then mag-continue na po to sila divide if it is needed. So ginabuhat to ni cell until na ma-reach niya or you have made enough cells. So how cells stop growing? Normal growth and healing is well ordered and precise. The cells know when there are enough new cells to heal a cut. A structure such as finger is fully grown. So ang cell is kanang mag-send po to sila kanang message to each other na sila kanang signaling. So that kanang mag-stop na to sila grow when growth or healing is complete. So mag-stop na to sila grow if ang healing or ang growth is complete na ang cell. So what is the cell cycle? The series of pieces that cells go through as they grow and divide. A continuous process, but we divided into 3 stages. So ang cell cycle is it divided into 3 stages. Ang number 1 stage is interphase, number 2 stage mitosis, and number 3 stage is cytokinesis. So remember na ang mitosis is kanang 4 phases. Ginatawag to siya na PMAT, which is ang P is ang prophase, and then ang M is metaphase, ang A is anaphase, and ang T is telophase. So madiscuss na to siya after aning cell cycle. And then we proceed to the interphase. So stage 1 interphase. So kaniyang stage 1 which is interphase. So ang cell life between division. So ang stage 1 is siya ang the longest stage. And then ang nucleus sa stage 1 which is interphase is still present ang nucleus. So there are phases. So ang gap O or G0 or gap 0 is growth and functions ang iyang function. And while ang gap 1 or G1 is nagduplicate sa organelles and molecules na needed sa cell division. So ang synthesis or ACE is nagduplicate sa DNA in chromatin form. And then ang gap 2 or G2 is siya ang mag-check for errors. So kana ang stage 1 which is interphase. So resting stage. So ang aim is siya ang mag-check for chromosomes attachment to spindle. Bali ang aim is siya ang mag-check sa mga chromosome na na-attach to spindle. So ang G1 is siya ang mag-check for cell size, nutrients, growth factors, and DNA damage. Kana ang i-check sa G1. And then pag-abot after sa G1, which is na resting state, which is ang G0, is mag-resting state na to sila. While after sa resting state, is musulod na dira ang DNA synthesis, which is ang ACE. So, ang sa synthesis or DNA synthesis, ang iyang trabaho is where the cell copies its DNA. So ang G2 is kanang yang i-check ang cell size or DNA replication. So bali ang G2 is mag-double check where all DNA copied correctly. Kung nakopid ba ang DNA correctly. Kana ang trabaho sa G2, which is mag-double check siya sa mga DNA kung nakapibatanan ang all DNA correctly. So kana ang trabaho sa G2. Sa G1, G0 ACE, DNA synthesis, and G2. So, stage 2. So, kaninang stage 2, which is mitosis. Duplication and division of the cell nucleus. And then, kato akong giingon na siya four phases, which is PMAT. So, ang first is prophase, ang M, metaphase, and ang A, anaphase, and T is telophase. So, kanang pieces sa mitosis is madiscuss na nato siya. And then, so, kana ang first pieces sa mitosis. So, chromosomes paired up. First and longest phase. So, ang prophase is siya ang pinaka longest na phase. And then, ang chromosomes ana is pair up pa. And then, centrioles appear, separate and move to opposite sides of the nucleus. Organize the spindle, which helps separate the chromosomes and attach to the fibers in the spindle. Nucleolus disappear, nuclear envelope breaks down. So, kani ang kuan sa prophase, which is ang mga chromosomes paana is nag-pair up pa ang chromosomes. And then, kaning diri is chromatin pa ni siya. And then, after sa chromatin, and then nanay condensation is kana iyang kuan. And then sa duplication, no, and then duplication siya, which is dira na makuan ang pair up of chromosomes. And then ang ikaduha na piece is metaphase. Chromosomes line up in the middle of the cell. Ang prophase is pair up na siya, while ang metaphase is ang line up sa chromosomes is na siya sa middle of the cell. Each chromosomes is connected to a spindle fiber at its centromere. So, ang mga H chromosomes is connected siya sa spindle fiber. Only last a few minutes. So, kani iyahang kuan, which is natanaw ninyong pictures na ang mga chromosomes is line up siya sa middle in the and then kanang color green is kanang ginatawag na spindle fiber, kanang color green, which is connected siya. And then ang ikatulo is anaphase. Chromosomes get pulled apart. And then ang sa anaphase is ang chromosomes get pulled apart. Centromeres split, allowing the sister chromatids to separate and become individual chromosomes. Chromosomes move into two groups near the poles of the spindle. This phase end when the chromosomes quiet moving. So kani ang kuan sa anaphase. Kana, which is nag-separate na siya. Separate ang sa anaphase. Nag-get pull apart na sila. Get pull apart na ang anaphase. The centromere split and the sister chromatids separate as each is pulled to an opposite pole. Nag-separate na sila. So, kanina ang telophase, which is, ang telophase is the final stage of the mitosis. Chromosomes tangle into dense material. Nuclear envelope reforms around the cluster of chromosomes. Spindle breaks apart. Nucleolus becomes visible in each new daughter cells. Mitosis is not complete yet. Cell division is due. So, kani ang kuan sa telophase, which is wala pa siya na complete og separate. So, pagdating sa pagdating sa kanang ni cytokinesis na nasa stage 3 is dira na ma-separate. Dira na ma-separate ang katong two identical na cells. Dira na ma-separate. So, kana ang kuan ni cytokinesis, which is dira na ma-separate, no? Dira na mag-result og two identical daughter cells. So, sa stage 3. So, mitosis plus cytokinesis result into two identical daughter cells. So, after mitosis, stage 3 cytokinesis, no? Pitching of the cytoplasm result into identical daughter cells. So, after sa mitosis, katong sa last pieces, katong sa telophase, no, wala pa to siya na separate, wala pa siya nag-resulting into identical daughter cells, is dira na mosulod ang cytokinesis, which is dira na mag-result into two identical daughter cells. So, cell mortality, cell lineage immortality. So, cancer cells are different from normal cells in how they grow, how they look, and what they do in the body. So, ang cancer cells and ang normal cells is different sila on how they grow, how they look, and what they do in the body. Even though cancer is common, there are actually many steps that our normal cells has to go through to become a cancerous cells. So, basic differences between cancer cells and normal cells. So, normal cells and cancerous cells. So, sa ang normal cells, no, ang makita ninyong differences, which is ang normal cells is kanang blue, and then ang cancerous cells is kanang red. So, many cells that continue to grow and divide. Ang dira sa cancerous cells. Many cells that continue to grow and divide. And then sa variation in size and shapes of cells. O, di ba, makita po ninyo no, ang ilahang variations o ang ilahang size and shape sa cells is different sila. And then sa normal cells, no, sa nucleus that is larger and darker than normal. So sa ang nucleus, no, sa normal cells o sa cancerous cells is different. Larger siya sa cancerous cells and darker po siya sa cancerous cells. While sa normal cells is dili. And then sa abnormal number of chromosomes arranged in a disorganized fashion. So makita ninyo no na ay ang sa cancerous cells and normal cells, sa normal cells is kanang arrange na siya correctly, while sa abnormal number of chromosomes is dili siya na arrange, which is disorganized siya. And then sa cluster of cells without a boundary. So ang cluster po nila no sa normal cells ug sa cancerous cells, ang sa cancerous cells is wala siya boundary. Makita po ninyo no. So normal cells and cancerous cells. So kani ang differences po sa normal cells and cancerous cells. So sa growth sa normal cells, stop when there's enough. Mag-stop sila kung enough na. And then sa cancerous cells is uncontrolled growth. And then sa communication sa normal cells, respond to signals from other cells. So na sila mag-respond sila signals from other cells. And then sa cancerous cells, do not respond to signals from other cells. And then cell repair rate. Each damaged cells are repaired or replaced. Cells are neither repaired or replaced. Ang stickiness or spread stay together in a assigned area, ang sa normal cells, while ang cancerous cells can travel solo and throughout the body. So ang cancerous cell is magtravel sila solo and throughout the body, ang sa cancerous cells. Ang appearance po sa normal cell is different siya sa normal and cancerous cell. Ang normal cells is uniform look under a microscope. Kung imong itanaw sa microscope is uniform sila. And then ang sa cancerous cells, ang cancerous cells is varied sizes, larger and darker center under a microscope. Larger sila and darker sila under sa microscope kung imo silang tan-awon sa microscope. And then sa maturations, no, sa normal cell is reach maturity, and sa cancerous cell is do not reach maturity. Sa evasion of immune system can be targeted and eliminated sa normal cell, while sa cancerous cell can hide and grow uninterrupted. And then sa function sa normal cell, perform designated task. Ang sa normal cell is maka-perform sila sa designated task, while sa cancerous cell fail to perform designated tasks. And then sa blood supply, blood vessels grow to feed normal growth and aid in repair sa normal cells, while sa cancerous cell, blood vessels grow regardless and constantly feeding a tumor. So makalid na siya tumor na cells. So other immortalized cell lines are in vitro equivalent of cancer cells. The cultural history of normal cells were divided into 3 pieces. So ang normal cells, ang cultural history sa normal cell is gidivide siya into 3 pieces. So ang phase 1 is represented initial culture. Ang phase 2, the period of exponential cell increase. Ang phase 3 is the date of cells. So there are several examples of immortalized cell lines. each with different properties. Most immortalized cells are classified by the cell type they originated from or are most similar to biologically. So, kani ang examples sa immortalized cell lines. So, E549 cells derived from the tumor of a cancer patient. So, ang E549 cells is nag-derive from the tumor of a cancer patient. So, ang HeLa cells, an extremely widely used human cell line isolated from a cervical cancer, probably derived from a epithelial cells. So, ang HeLa cells is one of the example po na siya sa immortalized cell lines, which is from a cervical cancer. So, ang HEK 290 cells derived from aborted human fetal cells and virus. Ang human fetal cells and a virus is HEK 293 cells. Ang JORCAT, a human T lymphocyte cell line isolated from a case of leukemia. So, ang 3T3, a mouse fibroblast cell line derived from a spontaneous mutation in cultured mouse embryo tissue. So, while ang virus cells, a monkey cell line. Ang virus cells is makuha na siya sa monkey cell line. Ang F11 cells, a line of neurons from the dorsal root ganglia of rats. Ang F11 cells. So, HeLa cells is a type in an immortal cell line used in scientific research. It is the oldest and most commonly used human line. The line was derived from cervical cancer cells taken on February 8, 1951 from Henrietta Lacks, a patient who died of her cancer on October 4, 1951. So, kana ang HeLa cells. Kana ang kuan sa HeLa cells. So, si Henrietta Lacks was an African-American woman whose cancer cells are the source of the HeLa cell line. So, si Henrietta Lacks is siya ang source na ang iyang cancer cell is kanang nagkuan siya cervical cancer, which is HeLa cell line. So, the first immortalized human cell line and one of the most important cell line in medical research. An immortalized cell line reproduces indefinitely under specific condition, and the HeLa cell line continues to be a source of invaluable medical data to the present day. So, si Henrietta Lacks siya ang pinakaunahang na babae na ang iyang cancer cell is the source of HeLa cell line. So, ang akong na-research pod na nganong gitawag siya kanang Henrietta Lacks, no, kanang HeLa cell line, kanang HeLa, kanong ginatawag na HeLa, it's because gikuha sa iyang pangalan na kanang HE is kan sa iyang Henrietta. And then sa kanang LE is a Lacks. Nganong ginatawag siya HeLa cell line, it's because sa iyang pangalan na Henrietta Lacks. So, virus cells are lineage of cells used in cell cultures. The vero lineage was isolated from kidney epithelial cells extracted from an African grain monkey. So, ang vero cells is extracted siya from an African grain monkey. The lineage was developed on 27 March 1962 by Yasumura and Kawakita at the Chiba University in Chiba, Japan. So, kanang vero cells is na-develop siya on March 27, 1962 by Yasumura and Kawakita at the Chiba University in Chiba, Japan. So, vero cells are used for many purposes including screening for the toxin of Escherichia coli, as host cell for growing virus, as host cell for eukaryotic parasites. So, kana ang use gamit sa vero cells, which is screening siya for the toxin of Escherichia coli, and host cells for growing virus, and also host cells for eukaryotic parasites. So, that's all for today's discussion. So, thank you for your listening and God bless everyone.